What up, math geeks? We're going to finish our lesson, or actually the whole unit on polynomial equations, by sketching graphs of polynomial equations. So we're going to take everything that we have learned in the entire unit and apply it right here to this lesson. This is the culmination of all towards which we have worked. And we're going to use everything that we've done. So we're going to sketch graphs without using any tools other than our brains and our writing utensils. And in order to do that, of course you know me, we're going to start with vocabulary. So if we're going to sketch graphs, we're going to have to deal with all the vocabulary from the unit that we have talked about. And one of the first things we talked about were factors. And if you remember the vocab for factors, they are stuff you multiply. Okay, so remember the vocab for factors, it's stuff you multiply. And when we were factoring, we were making things look like this. Why were we making things look like this? So we can clearly identify the factors. In this example, we have a factor here, 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 here. Those are the things that we're multiplying. Okay, so that's what factors are, stuff you multiply. And we went through factoring. We learned all these different methods to factor stuff, and we were factoring stuff. And then finally we got to that previous lesson, and we solved things. And we talked about solutions. And so what are solutions? Values of the variable that make a true statement. And so we learned about the zero product property. So we talked about values of the variable that make a true statement. We learned about the zero product property. Now we're able to identify solutions. So in this example, we know we have a solution at 0, x is 0. A solution at 6, x is 6, x is 1, and x is negative 4 because of the zero product property. So we talked about solutions. Now here's where things get tricky. What we have to do is make sure that we see the relationship between factors and solutions. See the relationship between this factor and this solution and this factor, this solution and this factor, this solution and this factor. So we have to see the relationship going forward and backward. Once we start seeing that relationship, we can start knowing two more vocabulary terms. So if you don't see the relationship between factors and solutions, now is a great time to pause, hit rewind, look at previous lessons, and make sure you have that down. Now, for two more vocabulary terms, solutions are also known as zeros because they're the values that give us the zero from the zero product property. They're the values that were given for the variable from the zero product property. Solutions are also known as zeros. Now when we get to graphing, solutions are also known as roots. Okay, so two new vocabulary terms, zeros and roots. And so we have to know this vocabulary as well, roots and zeros. Now roots and zeros, very basically, are the x-intercepts of a function. So if we have a function and we know the solutions, we know the roots, we know the zeros, we know where the x-intercepts are, we know where the graph will cross the x-axis. So all of this new vocabulary is just tying in together all these previous concepts, and light bulbs should start going on. So in the example we're working with, if we have solutions at 0, 6, 1, and negative 4, that means we have roots or zeros at 0, 6, 1, and negative 4, which means that those are the points where a graph will cross the x-axis at 0, at 6, at 1, and at negative 4. So that's all tying in vocabulary with concepts we should be good at. Now there's only one more piece of vocab we need, and that is end behavior. Now this is actually the third time we're talking about end behavior, or fourth time actually. So from challenge 5, from challenge 8, and from the very beginning, the guaranteed pass notes. Now end behavior is knowing what a graph looks like based off the parent function. And knowing what the graph looks like based off the parent function means we have to check our exponent and the lead coefficient. So we're going to check the exponent and the lead coefficient. So if we have our parent functions here, just like in the guaranteed pass notes, if we have our parent functions here, we've got to know what these graphs look like. So if we have a graph at y equals x squared, that's our parent function, then our graph is going to be a parabola opening up. If it's negative x squared, checking the lead coefficient, it's going to open down. If it's x to the third power, notice it's a lot like y equals x to the first power straight line, but it has a bump. So it's x to the third power opening up with a bump. If it's negative x to the third power, it's like negative x, but with a bump. If it's x to the fourth power, it looks like x squared, but with a bump. If it's negative x to the fourth power, like negative x squared, but with a bump. X to the fifth power, kind of like x to the third, another bump, opening up. Negative x to the fifth power, kind of like negative x to the third, opening down, another bump. Okay, so these are the types of things that we have to know in order to graph successfully. So if I take this just as an example, and I'm going to finish sketching the graph of our example, so let's take a look at the example we just worked with. What if we had, instead of that original equation, what if it was in function notation? So f of x is equal to 4x times x minus 6 times x minus 1 times x plus 4. How then could I graph that equation? Well, with three easy steps. Step 1, we find the zeros. Right? So step 1, we find the zeros. We set it equal to 0 and find the zeros. So we set it equal to 0 and we solve. And then we have our zeros. And then step 2, we graph our zeros. Right? So step 2, we graph our zeros. We know the zeros exist on a graph. And then step 3, we're going to check end behavior. Now, how do we check end behavior? The way we check end behavior is pretty cool. We multiply only the x's. So we only multiply the x's, and then we pay attention to the lead coefficient. So in this example, what we're going to do is multiply the x's. We've got 4x times x times x times x. 4x times x times x times x is 4x to the fourth power, but if it's a parent function, we don't even need that 4. It's just x to the fourth power. So we multiply our x's, pay attention to lead coefficient. We now know what this graph looks like. It looks like this, right? It looks like y equals x to the fourth. It's like a parabola with a bump. And so we can totally graph that function. We start with our end behavior. How's it come in? How's it come out? Comes in high, comes out high. So if it's coming in high, it means it's coming in from this way. And if it's going out high, that means it's going out high this way. And so we take care of our end behaviors first, and then we can sketch the rest of the graph based off of the other zeros. So we know it's going to be crossing here and here and here. So we just finish where it crosses. Crosses at 0, crosses at 1, and it crosses again at positive 6. So it crossed at negative 4, crossed at 0, crossed at 1, crossed at positive 6. That's kind of a rough sketch of our graph. So we now know if we had this crazy function notation, we could totally graph it. We find the zeros, we graph the zeros, we check the end behavior, put it all together, bam, we're graphing. So everything relies on strong vocabulary. What is end behavior? What are roots and zeros? What are solutions? And what are factors? Everything based on strong vocabulary. So if you have good vocabulary, this is going to be kind of fun and very doable. So here we have our examples. We're going to jump right in and start graphing them. So here's example number 1. We're going to sketch the graph of this function. And how do we do that? Well, remember the steps that we just did for the notes. I'll write them again. So if we have this function, remember the steps. Step number 1, we're going to find the zeros. Step number 2, we're going to graph the zeros. And then step number 3, we're going to look at end behavior. And then we can totally graph this without any tools, with just our brains and our writing utensils. So step number 1, find the zeros. How do we do that? How do we find the zeros? Well, we use that previous lesson on solving equations. We're going to set the whole thing equal to 0. So we'll set x plus 1 times x minus 6 equal to 0. All right, so that's how we're going to find the zeros. So step number 1, find zeros. Hopefully by now you've identified them as x equaling negative 1 and x equaling positive 6. So that's step number 1. Find the zeros, and we do that by setting it equal to 0. If that was challenging, then what you need to do is stop this video and go back to the previous lesson on solving equations. Step number 2, what we're going to do is graph those zeros. And so we sketch a graph, and we know we need to have at least 6 tick marks on the x because it's going out to 6, and at least 1 in the negative direction because that's where our zeros are. And we're going to sketch those zeros because zeros are also known as roots, which means that's where they're crossing the x-axis. So one's crossing at -1, one's crossing at +6. 1, 2, 3, 4, 5, 6, right there. So we have now accomplished step 2. And then step 3, all we're going to look at is end behavior. And how do we check end behavior? We're going to multiply only the x's. Okay, so multiply only the x's to see what's going to happen. So in our original function, we have a positive x times a positive x. And positive x times positive x squared. So when we're checking end behavior and we multiply our x's, we have y equals positive x squared. And we know from our end behavior that y equals x squared looks like a parabola opening up. So it comes in high, comes out high. All we have to do is sketch our graph. So it comes in high from here, comes out high to here, and what's happening in between? Well, it's just a friendly parabola. Okay, so we just finished sketching the graph of our parabola, and there's our graph. Okay, now in Algebra 1 and Algebra 2, you covered where's the vertex, you covered all that stuff with the axis of symmetry and blah, blah, blah. But for this purpose, we just want a general sense so we can start studying calculus, because this is more fun. Anyway, so that's how we sketch the graph of our functions. We find the zeros, we graph the zeros, and we sketch the graph using end behavior. So now we're ready for number 2, that second example here. This is a little bit more complicated looking, but totally doable, because we're just going to follow the steps. Right, so in the second function, we have everything already factored. That's nice and convenient. Right, so we have everything factored nice and convenient, and we're just going to follow our steps. All right, so step number 1, we're going to find the zeros. And how do we do that? We set it equal to 0. So we're going to set this equation equal to 0. Negative x times x plus 3 times x minus 3, and that's going to equal 0. So we set it equal to 0. Now it's clearly evident where our zeros are. X is going to equal 0. X will equal -3. X will equal +3. Okay, so just like the previous lesson on solving equations. Step number 2, we're going to graph our zeros. Right? Sketch your graph. We know we have to go out at least 3 tick marks in each direction. And we'll just put our x-intercepts down. Right? So lay those x-intercepts down. We got x is 0, bam. X is -3, bam. +3, blam. All right, so we have now graphed our zeros. And then step number 3, we're going to check end behavior. And how do we check end behavior? We multiply our x's. This is where we have to be careful. Okay, let's multiply our x's. We've got negative x times x times x. So negative x times x times x, negative times positive is going to be negative. So the lead coefficient is going to be negative, and x times x times x, x to the 3rd power. So it's going to be y equals negative x to the 3rd power. So that's why when we're multiplying our x's, we've got to be careful and pay attention to that lead coefficient. And now we know from our notes, right, our notes on end behavior, guaranteed pass notes, that this graph is going to look something like this. Okay, comes in high, comes out low. So it's going to come in from this direction, and it's going to come out from to that direction. Okay, so that's what that end behavior means. Now, what's going to happen in between? So it's going to cross here at 0, right? It has to cross at 0, so it's going to do something like this, like a curvy thing. So it's going to dip down here, cross here, and then cross at our last 0. And we have now sketched our graph using nothing but our brains and writing utensils, and that is so much fun. So that's how we are sketching graphs. So now for the third example. Third example is something a little bit more complicated. It's just telling us to do one extra step. So in our third example, we now have a function that is not factored. Okay, so we have negative 2x to the third power plus 7x squared plus 4x. Okay, so we have this thing, and we're going to have to sketch the graph. So how do we do it? We have to find the zeros. So number one, we're going to find the zeros. How do we do that? We set it equal to 0. Okay, so step one, we're going to set this thing equal to 0. And when we do that, we're going to realize something's weird. So remember everything we've done up until this point, we're factoring. Hopefully you see that we need to factor this. Okay, so hopefully you see now we have to factor this. We got to do some work. And when we're factoring this, I hope you see, you got to know this stuff, that there is a greatest common factor. So factor out the greatest common factor first. And the first thing I'm going to factor out is not just an x, but a negative x. It's going to make my end behavior a whole lot easier. So the first thing I'm going to factor out is a negative x. And I'm going to pause there. If what I just did was confusing, what I need you to do is stop this video and then go back to previous videos on factoring trinomials. Okay, so go back to the previous video on factoring trinomials and make sure that you are fully understanding that concept. So since we're good with factoring out this negative x, what will we have left inside the parentheses? 2x squared minus 7x minus 4, and that's what's going to equal 0. And now what we have to do is then factor this trinomial here. Okay? So whatever way you can factor that trinomial, do it. I will use the x factor method because I'm good with that one. And I'll see what happens. So the factors of 2x squared are 2x and x. What can I multiply to give me negative 4 here, but it's going to add up to a negative 7 eventually? I know already because I'm multiplying across the lines. If I had my 4 here and my 1 here, I'll eventually get to where it's going to add up. So how's that going to work? Multiply across my lines. I got 8x here. Multiply, I got my x here. How can that add to a negative 7? If and only if my 8 was negative and my 1 was positive, I would be good to go. So that means my 8 was negative, and where'd the 8 come from? Here. My 1 was positive, where'd the 1 come from? Here. I now know that I have factored this trinomial. So the completely factored form is negative x times 2x plus 1 times x minus 4. And that's what's equaling 0. So I factored it first, okay, and that's going to be the key trick. And remember, we have to keep in mind that because that's going to lead us to a whole other solution. So all of this for step number 1, find the zeros. So now we know x is going to equal 0. X is going to equal negative 1/2. And if that was confusing, hit stop now. Go back to the previous lesson on solving polynomial equations, and you should be good to go. And then x equals 4. Okay, so we have now found our zeros. So that was step 1, find the zeros. Step 2 is graph those zeros. So what we're going to now do is sketch the graph of these zeros. And I know I have to go out to 4, but since I have a negative 1/2, I want to space these out a little bit so I can have room for my negative 1/2. So I'm going to now graph my zeros. I've got a 0 at 0, boom. I've got a 0 at negative 1/2, which is right here, right, between 0 and negative 1. And then a 0 at positive 4. Okay, so I have now sketched my zeros. Now what I'm going to do lastly is check end behavior. And how do we check end behavior? We multiply our x's. Okay, so now what we're going to do is multiply the x's and see what our parent function is going to come out to be. Now we can either multiply our x's, negative times positive, right? Or we could look at the original equation. It was already multiplied out for us. Parent function is negative x to the third power. All right, so either multiply all the x's or pay attention to standard form. Either way, we know the parent function is going to be y equals negative x to the third power. And that tells us what our graph is going to look like. Okay, so if we know it's y equals negative x to the third power, we know it's going to open down with a bump, right? So it comes in high, comes out low, and it has a bump. So it's going to cross right about here, and then, I don't know, something like that. Who knows, right? But that's a good rough sketch of that graph. So with just our brains and our writing utensils, we can sketch the graph of polynomial functions. How much fun is that? Okay, so hopefully you have a good idea of how those graphs work. Now there's one more concept to cover to make sure that you understand everything backwards and forwards. I'm going to ask you some neat questions. Write an equation of a graph that has zeros at 3, -2, and 0. Let's see if you know things backward and forward. So for number 4, I'm telling you that x is 3. I'm telling you that x is -2. And I'm telling you that x is 0. So I'm telling you that. What you have to do then is write an equation. Your job is to take this information and then give me the equation. F of x equals blank, right? That's what you're going to have to do. So you have to know that relationship. Remember for the notes, I told you got to see the relationship between solutions and factors. Okay, so now what we're going to do is take that relationship and go backward. If we had a solution at x equals 3, that means the factor it came from is x minus 3. If we have a solution at x minus 2, the factor it came from is x plus 2. And if we had a factor at 0, or the solution at 0, the factor it came from is x, or even 4x, or 2x, or 1/2 x, or even -5x. So there's a lot of possibilities there. Okay, but that's just in general. So if we're going to multiply all these out, we have our equation. So we'd have f of x is equal to x times x minus 3 times x plus 2. That could be an equation, right? And if you want points, yay, there's that. But for me, I like standard form. So I'm going to put this in standard form. That's just me. So standard form means I'm going to multiply everything out. Okay, so multiply it all out. So if we multiply it all out, remember what we did from our unit in challenge 8, we can only multiply 2 things at a time. So the first thing I'm going to do is multiply these first two. X squared minus 3x. All I've done is multiplied my first 2 factors. And now I have my last factor. So I'm going to keep multiplying out. Okay? So remember, I could be done here, but I want to keep going because I like pretty looking things. So we have x squared minus 3x times x plus 2. Multiply it out. X to the third power plus 2x squared minus 3x squared minus 6x. And if you want to use the area model, you can do that as well. So I'm checking my math. I think I'm good to go there. Now I combine like terms. X to the third power minus x squared minus 6x. And that is my standard form. Okay, so standard form is f of x is equal to x to the third power minus x squared minus 6x. And that's my pretty looking equation. Okay, so I can have that equation for standard form, and I can also have in factored form either one, but I am more particular to that one. And that is it. Now you know your equations inside out, front, back. You can graph. It's all good part of the unit, so everything is now fit in nicely. This stuff was awesome. It's my favorite thing in all of algebra, so I hope you enjoyed it. Bye!